Thank you for inviting me to this forum. It's a great pleasure for me to be here and speak to you. So I speak to you about the innovation in aviation. So the top aircraft you can see here is the Boeing 707. This aircraft was launched in the year when I was born, so quite a long time ago. And this aircraft was a game changer because it really established the age of jet travel. In 2015, where we are now, we can see the latest product entering service, the A350. And when you look from the distance to the two aircrafts, you're wondering how 60 years of technology, evolution, of innovation has found a change. Because when you look to it, we still have tubular fuselages with the tails at the end. We have swept-back wings in the middle of the fuselage with engines below them. So from the distance, it looks not radically different. However, when you look about the engines, you already see that there's a tremendous change because the newer engines are much, much bigger than the ones we had in the 1950s. And when you look to what we have achieved over the time, it's quite remarkable. Each of the red triangles here is symboling one new aircraft which has then entered service at a given years. And you see that the fuel burn has been drastically reduced over the 60 years. The noise level has been reduced. The safety has been increased. So a remarkable improvement. So the question is now, and you can see it on the curves, is getting flatter and flatter. If in the next 20 or 25 years, we want to further reduce the fuel burn by another 50%, which is our goal, we have to invest a lot more technologies in innovation to really make this happen. And this is a bit what I want to talk about with you. Before I talk about this, I would remind you on some of the breakthrough technologies we have seen in this time, the last 50, 60 years. First of all, there was this wonderful aircraft, the Concorde, the first supersonic transport aircraft, which unfortunately has not found a sufficient market, and there have been other reasons why it has been stopped. But many of the technologies which have been developed for this aircraft have found their way in other products. In '74, we have seen then the first wide-body aircraft with twin big engines. This was followed in '82 by an aircraft which then was being flown by only two pilots, which established a new standard in the industry. Followed then in '88 by the first full fly-by-wire aircraft, which again put a standard in the industry, which allows today even a big aircraft like the A380 to be flown by only two pilots. And in 2005, the A350 was flying the first time. It was the biggest aircraft, or is the biggest aircraft for passenger transport, and has a full double-decker fuselage. And in the recent years, we have seen then the complete full composite aircrafts made out of carbon fiber, which again is a big step forward. So the question is now, what next? What are the next technologies we have then to put in the marketplace to answer the challenges of our industry? And before I come to this, I want to quickly remind you to the challenges we are facing. So, flying safely and having access to flying is very important for our society and our global economy. And what we can see since 1971 is that every 15 years, the amount of traveling is doubling. And we can see as well the trend following for the next 15 years. And this means today, in 2015, more than 3 billion passengers are using our transport aircraft, and in 15 years only, we have to transport 6 billion passengers per year. So this brings problems with it. There's the congestions of the airports, of the sky, the air. We need to take care that we don't pollute the environment, so we have to reduce the fuel burn even more, and so on and so on. And these challenges can only be mastered by introducing new technologies, very innovative technologies, to make this happen. And the question is now how we can then make a big step forward compared to the last 60 years evolution, where we have not seen a dramatic change in configuration. So we will have to think about what will be the changes, the game-changing technologies, which bring us then to a situation where we can then master these challenges. And starting on this with aerodynamics. So in aerodynamics, for many years, we know that we can further reduce the drag and increase the efficiency of our wings if we would go to laminar flow. However, what stands in the way so far is that we need a very accurate wing design, which as well maintains the shape and the smoothness of the wings while flying. And if you want to bring something like this into service, you have to be very sure that you can produce it and you can then maintain this type of shapes in flight. In order to demonstrate it, we are just preparing a big demonstrator. We take an old A340 aircraft, cutting off the outer wings and replacing it by new wings, which would reassemble a big part of the new wing of a new short-range aircraft. And with a lot of instrumentation, we can then measure in detail the deformations during the flight, the waviness of the surface, and as well how much laminar airflow, boundary layer airflow we have, and then how much drag saving we can obtain. So this is the next big step in aerodynamics. There are as well other ways to achieve laminar flow, and we are working on them as well. But this demonstrator will be ready to fly by the end of next year, and then hopefully we will confirm our estimations. And in order to check if we have the right technical solutions, we have different design solutions for the left and the right wing. So when we have then achieved some progress in aerodynamics, the next thing we have to do is then to reduce the weight of the aircraft. And here we have different means. So I spoke before that we have carbon fiber now established as the key material, the reference material for our aircrafts. And we see still a lot of evolution on carbon fiber. And this year I was very impressed to see some students who have brought up some ideas that they can integrate in the carbon fibers some capabilities by special coating, special material, which would allow the carbon fiber, when the aircraft is flying and the wing is moving like this, to harvest some energy and store the energy in the carbon fiber. I don't say this is a big step forward, but it shows us what you can do with this material if you introduce other functionalities. So we're thinking about putting in the carbon fiber some wiring, which is very simple. We have as well some ideas putting some type of small bubbles of glue in it. That means when there's a small crack, this bubbles opens and fixing the crack. So it's more or less self-healing. So that's another step which will help us then to reduce weight, because then we can eventually even more aggressively design the aircraft. Another revolution in front of us is what I call 3D printing or added layer manufacturing. And here you can see one bracket we have designed some years ago and which is part of the A350. And we are just introducing this part because, first of all, it is lighter. You use less material when you build them, but you as well can use very different designs and design the aircraft, the elements in the way that you best follow the loads, the stress level in these materials. So we call it bionic design, for example, because we learn from the nature. So when you look in the details of our bones or in the trees, you can see structures which have been evolved over millions of years, and we can learn from it and use it then for our design. And at the moment we are starting and bringing the first parts in the aircraft, but we have as well visions that we can go to bigger and bigger parts, and hopefully in a few years or maybe in 10 years we can even then print complete structures of a fuselage, as it is shown here as an example. Another question is then how we can compensate the cost of the new technologies in the future by reducing the cost of the manufacturing. And here in Airbus we have a project called Factory of the Future. It's this video showing us how it shall work so that we can fully digitalize the process from the design to the manufacturing, including the supply chain, so that while building the aircraft we develop as what we call a digital twin. So we have detailed information about the detailed build of the aircraft. In the build process, the components are communicating with the tools, with the worker. The worker is permanently linked then to the computing system, the manufacturing execution system, so that we have a full tracking of all the activities, and the drill or the torque tool knows exactly what information is needed at that position where it is working. And then the components, when they have been manufactured, they will be 3D scanned, so we have the accurate dimensions of this component. So when we fit them together, it can be positioned so that we get the most accurate assembly of the different components. And while then fitting them together, we are using more and more robots, because robots are more easily repeating what they have done. So we have a higher quality. For example, here, if we would use a robot inside and outside the fuselage, so we can fix the components together. If it would be a fuselage made by thermoplast composite, it's type of welding. There's another interesting technology that you print the electronics and the cables, so the wirings, in the inner surface, and by this you save all the weight and all the complexity of the installation of the wiring in the aircraft. And finally, the painting of the aircraft will be done like printing, and this is already reality, not for the complete fuselage yet, but for example for the tails of the aircraft. We have the first trials running with very good success. And here we have the final assembly of the wings with the engines, and then we have to establish then the cabin monuments and the seats, and then the aircraft is ready to fly. So here we have it. So this is the manufacturing side. Next step is then the propulsion system. So the latest propulsion system, the geared turbofan, are just in the flight testing and will be certified soon. And we see that as a further evolution of the size of the engines, making it even more efficient. And the challenge for us is then to integrate these big engines in the aircraft. For example, if we integrate it under the wing, there will be at some size, there will be no more space enough. We have to put them in other places. Or we see counter-rotating prop fans, and here we have already wind tunnel tests demonstrating that with today's design tools, we can even make such noisy propellers silent enough so that we can then fulfill the noise requirements and gain more efficiency in the future. So the interesting thing here is that with these new propulsion systems, we will have more design freedom than we have today. And this will not only open up, it will require that we open up the design space and look into completely new configurations. Some of the examples you can see here. And another example on the propulsion I've not mentioned before is electrical propulsion. So we in Airbus group, we have started to experiment with our EFAN aircraft. We've even flown this over the channel between France and UK this summer. We are working on hybrid propulsion for the bigger aircraft, where we combine an installed engine in the aircraft which generates electricity, and this drives then some fan placed somewhere on the aircraft where they hopefully then even benefit the aerodynamic flow, and by this we can then compensate the extra weight and gain more performance. So many things are feasible. At the moment I cannot tell you what will be the right configuration in the future because we are exploring many of them. But what I can share with you is one of the vision we have put in a small video to animate our engineers and our partners to think a bit more out of the box and come up with some more radical solutions.
Will we still be stuck on gridlocked roads? Or will we finally opt for the third dimension? Vertical takeoff would be one way of gaining space in cities. We might even have flying aircraft carriers for our long-haul flights. Will we want to reach our destination in less than 3 hours? Whatever the distance. Or simply decide to take our time and enjoy the comfort on board.
So I hope this was as well fascinating, animating for you, and I hope that many of you have now the ideas we need to collect to make this aircraft reality. So for sure it will take a long time before we see flying aircraft carriers, but I think it will not take too long before we see flying individual vehicles which can then use the third dimension in the cities, because this is needed, and you can see in several places in the world already people working on this concept, and as I said, it will not take too long. So this is what I wanted to share with you. So we have a lot of challenges in front of us, which we can only master by innovative solutions. And so we have some visions, but now I think we have to work on them and to find the right combinations of materials, of aerodynamics, of configurations. And I believe if somebody is then really getting the right configuration with the right propulsion system and the right technology on the avionics, for example, other systems, integrated in a well-mastered, multidisciplinary end-to-end design process, this can be the game changer of the future. At the moment, I don't know how it looks like, but I hope that very soon we will see them on the drawing boards. So eventually, the fuselage then might look like this one. So This little boy is my grandson, so he was born this year when the A350 entered service. And you can see already he knows the configuration of an aircraft, and I believe in his life he will see new configurations. And then a few years later I can talk then with him about this, and hopefully his life then, and as an aeronautic engineer I suppose, will be more interesting than mine. Thank you very much, and I hope you enjoyed this short presentation.
Thank you so much, Axel. And if you don't mind, I'd like to ask you two questions. The first one, well, you have been talking about the nearest future, and what will change the industry in the next, I don't know, 50 or 100 years? And the second question is, what should we do to make it happen?
So what changed the industry? I hope that we find a solution for this electrical flying, because we need to find a way to get away from the standard fuel we are using today. And to generate some electrical energy might be much easier than to replace the existing fuel. Second, I believe that 3D printing, as I mentioned, is just at the beginning, and there will be a revolution in the world. The complete manufacturing industry will change, and we will produce the parts then close where they will be needed in the final assembly and so on. So this is a real revolution. So what is needed is, what I can see today is to bring the best ideas together and to benefit from the brains we have globally. I think we have to find ways to even more bring people together and let them work together. When I mentioned briefly that I was fascinated by the students who have come up with the idea of generating or harvesting electricity from the vibration of the wings and storing it in the future. These students have built a team without having seen them before. They worked on different places, 5 different places, come from different continents even, and work together as a virtual team and come up with such a brilliant solution. I think for me this is a way of working I can see as a reference for the future. And honestly, today I was here in the exhibition, and I've difficulties to understand all the Russian language there, but I had some help to get the understanding what's going on there. I spoke to a few people, and I can see the thinking here is not different from the thinking I can find in Toulouse or in Bangalore or in Beijing. So everyone has ideas how he can contribute to make the world a better place and to improve the products. So we only have to make it happen.
Great. Thank you very much again. Thank you for a great presentation, and I do hope to see you again in Moscow next year.
Pleasure.
Thank you so much.